Okay, so it's asking us to write the equation of the hyperbola centered at the origin with length of horizontal transverse axis 2, and the curve passes through the point 5, -8. Interesting little question. All right, well, we need we don't have to draw a picture, but it'll sure help. I really would suggest it. Not required, but probably very helpful. So I'm going to do that. Let me try drawing that thing. So come on in here. And okay, so now I'm going to draw it. Now, the first thing you need to know, are the branches going to go up, down, or right, left? Well, let's see what it says. Does it say anything? Yeah. See the words down here? I don't know if I've called your attention to these words before, but take a look at these words. Oops, I'm trying to scribble them, I'm trying to erase. All right, so down here, notice it says horizontal transverse axis. And this one says vertical transverse axis. What does that mean? So this is vertical axis here, and this one's the horizontal axis here. So in other words, the transverse, trans means across, whenever it's like transport means to carry across. So transverse axis is the axis that cuts across the branches. See how that, here's the branches, and see how that line cuts across them? Whereas here on the second one, the branches are up, down, the line cuts across them. So it tells you the direction the thing goes, right? If you have a horizontal transverse axis, then it's a horizontal line and the branches go sideways. If you have a vertical transverse axis, then it's a line going up and down, and the branches go up and down from that. Right? We good there? So okay, so what are we gonna do about that? Well, that means on this problem, they said, yeah, where's my problem? Here it is. They said that it's a horizontal transverse. So that means the branches go sideways, don't they? Horizontal, right? See that? Horizontal. It's this case where the branches are going sideways. Okay. So, and where are they? With length of horizontal axis 2. What does that mean? The length 2. That means, that's kind of a funny situation. That means it only goes over 1 and back 1. Wait, how did I know that? Because this axis is 2, which means it's over 1 and back 1, a width of 2. Let's take a look right here. So the transverse axis is like from here to here. From there to there is the transverse axis. You see that? That's the width of that axis. So on this one, they're telling us the length or the width, what do you want to call it, of the horizontal transverse axis is 2. That means this is 2. So it must be right 1, left 1. Okay. So what does that mean? Let's start writing the equation. So if it looks like this, the equation must be like that, right? X is in the front, not Y in the front. Y is in the front when you go up, down, but ours branches are going right, left because we have a horizontal axis. So X is in the front. Let's write this equation. So I'm going to say, okay, x squared over a squared minus y squared over b squared is 1. And what's going to go underneath x must be 1 squared. How to come up with that? Because however far to the right, 1, however far to the left, -1, that's what you put underneath x squared. So 1 or -1 squared, either way, same thing, it's just 1, right? That's what's on the graph. Let me show you on the graph, right? See, this is over a, and what goes underneath x? a squared, or you could say it's back a, same thing, squared. So however far to the right or the left the box goes, a, that's squared goes underneath x. So ours goes right one, left one, so that squared goes underneath x. Okay, so we're to here. Now, one more thing. They're giving us the curve passes through the point 5, -8. So over 5, down 8. I don't know what it is. 2, 3, 4, 5, down 2, 3, 4, 5, 6, 7, 8. So that the branch actually goes way down here. So really, I should have made the branch go more like that. Here, I'll do my best. Boom. There we go. So the branch is hitting the point over 5, down 8. This is down 8. This is over 5. So that means the branch is passing through the point over 5, down 8. What does that mean? Well, remember what any graph means at any time. A graph is a million little dots, millions and millions of little dots that all make the equation true. That's what a graph is. It's a picture of the truth, a picture of all the points that make the equation true. Okay, so what? So that means if I plug in x is 5 and y is -8, that point's on the graph. That point's got to make the equation true. So if I bring back the 5 for x there and the -8 for y right there, plug it in, it's got to make the equation true. So I get 5 squared over 1 minus y, which is -8 squared over b squared. I don't know what that is yet, is 1. So I just have to find b now, you realize, because they want the equation. Basically, here is the equation. That's what they want, write the equation. I've basically got the equation, except I don't know b squared. I just have to find b squared, and bang, I'll have the equation. So I need to solve this for b squared. So this is going to be 25 minus 64 over b squared is 1. Right? Okay, so what am I going to do now? Well, let's subtract 25 from both sides. Like that. Boom, boom. And so what do we get? Minus 64 over b squared is 1. Take away 25. What's that? Minus 24. We good to there? Now, what do we do with negative? Well, we just cross multiply now. I'll put this over 1, diagonal, diagonal. So we get minus 64 times 1 is minus 24b squared. All right. So this means minus 24b squared is minus 64. Minus 64 times 1 is just minus 64. Divide by minus 24. Like so. B squared equals, and so you could just do that in your calculator. I'm getting a decimal. You could do it on your calculator, or you could just say, look, I'm just going to leave it. I'll show you two ways. 64 over 24. If you divide it, the two negatives cancel. Divide in your calculator, you get 2.66666 forever. That's fine. Or you could just reduce that thing. Divide by 8. Top and bottom, it would be 8/3. B squared, just reduce it. Either way, you could put this in for b squared or this in for b squared. It'll take it either way. Both are right, true, and good. Either one, decimal or fraction, whatever you like. They're both. Now, I don't need to get to b. You might say, well, shouldn't we square root it to get to b? No, I don't actually want plain b. I actually want b squared. That's actually what's more useful to me on this one is b squared. So, right? How do you know that, Mr. Amber? Look right here. Remember, this is basically the equation right here. All I had left to find was b squared. So that, I don't need b, I need b squared. So that is the equation. They asked me to write the equation. So that is the equation. I just need to fill that in now. So let me bring that down. So that is x squared over 1 squared minus y squared over b squared is 1. And so you can write x squared over 1. You don't need to write 1 squared minus y squared over b squared. You could write 8/3 if you want. it'll take it that way and be very happy with your answer. Or if you don't like that, you could write x squared over 1 minus y squared over, and you can put the decimal in, 2.6666, like that, a whole bunch of sixes, equals 1. And it will be happy with that one too. They're both right. They're both true. They're decimal or fraction, either way. What did we do? We found the equation. We found the equation of the ellipse that, of the hyperbola that does what they're saying, right? What did they say? They said, write the equation of the hyperbola, centered at the origin, length of horizontal transverse axis 2. So that's how we knew this was 2 wide, 1 to the right, 1 to the left. So that's 1 squared underneath x, because right, left is underneath x. Didn't know what's underneath y, had to find that, plugged in the 0.5, -8, 5 for x, -8 for y. Came down here, solve for b squared, 8/3 or 2.6666. Plug that in, 8/3 or 2.6666 underneath y, and you've got the equation. There we go.